Okay, this worksheet is in the back. You should have picked it up when you came in. It is not a grade. It is totally for your own benefit. The quiz looks very much like this, different numbers, okay? It does, at the bottom, also say that there are some questions on equation of a line through 2 points, parallel, perpendicular, all that kind of stuff, okay? So there's review stuff on there. You cannot use a graphing calculator for this quiz. I did move the quiz till Thursday, and I have 6 or 7 scientific calculators I can loan out, but I hope most of you have or can get your hands on a scientific calculator, yes?
This is not a grade.
That's right. We're recording, so they'll know that you came in. All right. Everybody got that? Any questions on that? So tomorrow I will ask if you have questions you want me to do on this. Does that make sense? Because the quiz has been moved to Thursday. So tomorrow I will ask if you have any questions on this worksheet. All right. For today, whoa, that's not what I wanted to do. For today, this is what you need to do. Worksheet 6. You also need a graphing calculator. Worksheet 6 and a graphing calculator. We need to go kind of quickly today. I had trouble finishing the notes, but I'm thinking you guys will be all right. Sometimes it's harder to keep up when there's 35 people and everybody's trying to chat. All right, there are 3 kinds of polynomial or of quadratic equations written across the top here. All right. The first one is polynomial form, and I'm having trouble with my cursor here. Just, I don't know what's going on with my tablet. Y equals ax squared plus bx plus c is just polynomial form. Okay? This form is not particularly helpful for finding the vertex. If it factored, it would be helpful for finding the x-intercepts. It is pretty easy to find the y-intercept in this form. I'm going to show you how to do all of this algebraically today because there is a part of the SAT that is no calculator. There is a part of the AP Calc test that is no calculator. Okay? These are very easy no calculator questions that they could ask about. That being said, I am not going to ask you to find this information out about a parabola, like the vertex and everything, without a calculator. Okay? Just putting it out there. All right. X-intercepts is when you set y equal to 0. So this particular one would say 0 equals 2x squared minus 4x minus 6. If I divide all that by 2, x squared minus 2x minus 3, does it factor? Minus 3 and plus 1, right? Did I do it right? So where are the x-intercepts at? Yes. The x values are 3 and negative 1, and I would like you to write them as ordered pairs. So it would be 3, 0, and negative 1, 0. And this is going to be a very rough sketch. Okay, if the x-intercept was when y equals 0, what do you think? The y-intercept is when x equals 0, which means I can just put in a 0. 2 times 0 squared minus 4 times 0 minus 6 is negative 6. Everybody all right? So this is 0, negative 6. So down here somewhere at negative 6 is where it's crossing the y. All right. The vertex could be found by using your calculator. Which way does this one open? It opens up, So would this have a minimum or a maximum point? Minimum. So this, you could use the minimum, and we'll do one like that. We'll use the calculator to do one in a minute. I would like us to learn what's called, what I call, it's Hofbauer's name for it, the vertex finder recipe. It's actually Miss Falzone's name for it. Okay, that recipe is, does this look familiar to anybody? Okay, that's a piece of the quadratic, right? If we got rid of the square root, we'd have an opposite of b over 2a. That finds the axis of symmetry, which also means it finds the x value of our vertex. All right, I wrote that all over the place, so there's really no room for work, but if I did from this problem right here, x equals a is 2, b is -4, and c is -6. Everybody okay with that? One class earlier today didn't know where I was getting those numbers. We're good with a, b, and c? Okay, opposite of b would be 4. Over 2a would also be 4. So we get 1. So the vertex has an x-coordinate of 1. If we were finding the axis of symmetry, its equation would just be x equals 1. Anybody notice anything about the -1 and the 3? The axis of symmetry is always exactly in the middle of the x-intercepts. Does that make sense? It's down the middle of the parabola, right? Okay. So you could have added -1 plus 3 divided by 2 and gotten 1. Okay? How do we find the rest of the vertex point, the y-coordinate? We just plug it in. So it's going to be 2 times 1 squared minus 4 times 1 plus 6. That's 2 minus 4 is -2 plus 6. I did something wrong, didn't I? Oh, it's a -6. I'm like, that's not what I remember getting the rest of the day. Okay, I wrote this down wrong. Sorry, it was -6. So it's -8, I think. So down here somewhere at +1, -8 is the vertex. Oh, I kind of hit the points. Kind of wrote over the top of that one. This is actually called f of x because we plugged the x back in to find the y coordinate, okay? All right. Yes? Okay, guys, how did we get the -8? We found the 1. Do you remember how we found the 1? Okay. Then we plugged the 1 back in here. Sorry, I should have written here equals -8. That's how we got it. We plugged it back in, okay? I didn't show where I got that. Better? Okay. Thank you for asking. I don't want you to be confused. All right. Yesterday we wrote vertex form, and it looked like this, x minus h squared plus k. Do you remember that? Okay. The a is the same in both of those forms, okay? It's just the stretch. Now, what's the easiest thing to find on this equation form? Vertex. Thus, it's called vertex form, okay? Where is the vertex on this one? -5, -4, okay. Now, I'm going to tell you right now that the y-intercept is going to be like almost -80. So I'm going to make my scale really tiny. Over here is -5, -4 somewhere, okay? And that's not even tiny enough, but we don't really care. We're just estimating. All right. How do you find the x-intercepts? Plug 0 in for y. Does anybody have a... Oh, she's a genius. She said there's not going to be any x-intercepts. Does everybody know why she said that? It opens down, right? And the vertex was down in this quadrant? Okay, let's see what happens. Just because this is supposed to tie together in your head, okay? It's also a great question for tomorrow's quiz or Thursday's quiz. Algebraically, you would add 4 over here. Everybody good? And then what would you do? Divide by -3. Oops, I forgot the squared. And then you would square root both sides. Okay, so you'd have x plus 5 equals plus or minus. You'd get 2 over, and somewhere there's an I. It doesn't matter if it's top or bottom. But you'd have square root of 3 and an I somewhere. Okay, doesn't matter. All that matters is it was imaginary. So do you understand that solving and getting an imaginary answer means that there are no solutions in the real world to where it's going to cross the x-axis? Okay, so we're going to write none here. Then the last one, how do we find the y-intercept? X equals 0. So we just plug in a 0. So we have y equals -3 times 0 plus 5 squared minus 4. Be careful, it's not -4. You don't get to throw away all that other stuff, right? This becomes 5 squared is 25 times -3 is -75 minus 4 more -79. So way down here somewhere, I'm just going to pretend that's -79. Now, somebody's going to draw this going up and thinking this is one of the points. Do you remember what this point really was over here? It was the vertex. So it's going down, and it's actually probably very, very skinny. If we had a proper scale, we're just going to pretend. We could make it as wide as we want by changing the scale of our graph paper, right? That's why the calculator can distort things very easily. Depends on what your scale is, your window. All right, what do you think this one's helpful for finding? Okay, the x-intercepts, because it's in factored form. So for the x-intercepts, we just set y equal to 0. So we have 1/2 x minus 5, x plus 3. Where are the x-intercepts? Okay, does this 1/2 do anything? No, because 1/2 can never equal 0, right? If there was an x out there, then it wouldn't be a quadratic anyway, but it would have a 0 at 0. But this has zeros at 5, 0, and -3, 0. Sorry, that negative is kind of funky. So over here at 5, and over here somewhere at -3. Now, y-intercept, how do we find that one? Plug in 0. 0 minus 5, 0 plus 3. Yeah, -15 halves or -7.5. Okay. Several ways we could find the vertex. By the way, I never wrote the generic form up here for you. It would be A, and then you'd have to pick some different letters because it's not H, K, and we already used B and C on that other one, so it might be like X minus D and X minus E, whatever. Okay, I'm just trying to give you a generic form of this. I really don't care. You don't have to write it down at all. Anybody ideas? I don't want to FOIL it together. Anybody remember something I just said we could do to find the vertex? Other than graphing it on our calculator? To do the vertex finder recipe, we'd have to FOIL it all back together and distribute the 1/2. Do you remember? Yeah, less fun. Do you remember what I said about halfway? -3 and 5. Halfway in between there is what? 1. So the vertex has to have an x-coordinate of 1 because the axis of symmetry is at x equals 1. That's what you would get if you did vertex finder, but that seemed a lot faster to me than foiling it all out and everything. Now what? How do we find the rest of the vertex? Plug it in. So we have 1/2 times 1 minus 5 times 1 plus 3. 0.5 times -4 times +4, -8. Anybody get that? Okay, so we got 1 -8. And that is a really bad parabola.
It's okay, let's go to mine. When did you can go through the vertex?
Mine's a demented parabola. All right, I'm going to practice a couple quick things here. We're going to practice changing this to x-intercept form. Well, what's the other name for x-intercept form? Factored form. So what are we going to do? Just factor it, and it factors how?
What if it didn't factor out? We really want to change it to x-intercept form. Or we just say
If it didn't, yeah, you'd have to find the x-intercepts. If it totally didn't factor because it had imaginary solutions, then it wouldn't have x-intercept form. But yeah, it's not going to ask you if it doesn't factor, honestly, because there would be no point. I mean, if the answers were, you know. Yeah, it is. Just checking. It's -5 and -1, right?
Yeah.
Thanks.
I'm trying to think of it. So you would just do like
If the answer, like the x-intercepts were at 2 plus or minus the square root of 7, there would be no point in writing it in this form, and so I wouldn't ask you. Okay.
But if it did ask you, just tell them no.
All right.
X-intercept form, no.
Change to vertex form. Guys, I need you to listen closely. There are 2 ways you can do this. You probably learned to complete the square to do this last year. Okay? And I will do it that way. But it is possibly for some of you faster to use the vertex finder recipe. Okay, what is the vertex finder recipe? Opposite of B would be 4 over 2 times A, which would be 2, so we get 2. Okay, plug that back in to find the vertex. So we do 2 squared minus 4 times 2 plus 1. I think -3. All right, so we now know the vertex is at 2, -3. Can you write that in vertex form? Y equals A times x minus the h of our vertex, which is 2, plus the k of our vertex, which is -3. So you could just write -3 on the back. I left a blank here. What's our A value? Do we have to do a bunch of work to find it? No, it's just our stretch, so it's just 1. Now, I'd like to remind you how to complete the square on that one. If I were doing this by completing the square, I would have moved the 1 over to this side. Do you remember this? Then you would complete the square, take half and then square it, add it to both sides, and then just subtract the 3 back over to this side. Is that what we got here? Same thing? Okay. I'm going to do this one in a separate sheet because I don't really have room, and it's not going to go well because I wrote over the top of it, but we'll fake it. All right. Can you watch me do completing the square on this one? I think most of you would not choose to do completing the square. Does anybody know why real quick? Because that 2 is going to make this painful, okay? You would go y minus 7 plus blank equals, you would have to factor out the 2. How is that going to factor out? Okay, x squared minus 6x plus blank. Now, I did this question right the first time this morning, and the second time I was talking and didn't do it right, because when I factor this and take half of the 6 and then I square it, what am I actually adding to the other side? Right there, I need to add an 18 over here, which makes this plus 11. And then you'd subtract the 11 over to this side, and you'd have y equals 2, x minus 3, quantity squared minus 11. Most of us would not have chosen to do that. Okay. Yes, the faster way that I'm going to suggest is you use your vertex finder recipe. I can talk. Negative b over 2a would be 12 over 2 times 2, which is what? Okay. Then what do? Plug it back in, which is 18 minus 36 plus 7 is negative 11. So you now know the vertex is at 3, negative 11. So it's really fast to just write what? Where did y'all get a 2? You're absolutely right. But remember, the 2 was from here. We already knew what that number was going to be from up there. And then we put in okay. All right. Some of these are very easy. Some are not in a form where it's easy to pick these things out. We are going to do one of these on the calculator, or even 2. We'll see. Quadratic are written in this form. We're supposed to identify the vertex, the line of symmetry, if I could use my, and what direction it opens. So for A, can you tell me the vertex? Okay, and line of symmetry? The definition of line of symmetry is it going to be a vertical or horizontal line if our parabola is opening? Which way is this one opening? It opens up. If it opens up like a U, the line of symmetry is vertical. So it is, what is it? Yes, it is x equals, are we all right back there? Oh.
You said that's so matter of fact.
The line of symmetry is always just x equals h, okay? Which is also x equals negative b over 2a. But do we know what a, b, and c are in this form? I only know what a is, right? Okay. So help me with b real fast. What's the answer to b? Negative 3, 7. The axis, or the line of symmetry, or axis of symmetry. X equals negative 3. And why does it open down? Yep, negative a out here. Okay, what's wrong with this one? It's in the wrong form. Okay. Do we have more in the wrong form? Yes. Let's do this one by vertex finder, and then we'll do the next 2 by calculator. How's that sound? Okay. Vertex finder to find the vertex. Negative b over 2a would be 6 over 2 times 2, which would be 3/2, or 1.5. You can use 1.5. I don't care. Now plug it back in. Is it 8.5? Yes? Did I do it right? Okay, so the vertex, I don't care which form you write. Axis of symmetry, x equals 1.5 or 3/2. I'm good either way. And it opens. All right. Any questions on those so far? All right, I need everybody to graph this on their calculator for the next question. Because I need to know that we all remember how to do this or are learning how to do this if you've never used the graphing calculator before. So it's -3 and the y equals, okay? Y equals in the upper left-hand corner. Y equals -3x, and the x is the key right next to the alpha. You have to use this x key. Well, I'm not actually positive you have to, but please do. You have to use the other x down here, the alpha x, and I think it works, but it won't work in other modes, so. It's above the store button. Did you find it? Okay, -3x² plus 18x minus 1. All right. Now, I want us to try this in a standard window first. So that's zoom 6. Is this a good window? I see the x-intercepts. I even see the y-intercepts. It looks like it's going through the origin. But I can't see the vertex. So what do I need to change? Do you guys need help? Besma, are you okay? No? Who's good with calculator stuff? Can you go help them, Claire, for me? Yeah. They have limited experience with the graphing calculators. Thank you so much. All right, guys, the window is kind of confusing. What do we need more of? We need the y and the y max to be bigger, right? So we go to the window. 20, 40, it doesn't matter. It's the y max. Does 20 enough?
No, probably not. Because 40 is still very much top.
Oh,
My parabola is not very straight.
50 is better?
What did I look at? 100. There's a bump in my parabola.
Her parabola is red.
It's not a super big bump, but there is a bump like right here.
It's not very straight.
It's not very straight at all. Her face, she's like, that's not normal.
No. All right, what are we actually trying to find in this problem? The vertex, which is called the maximum. Can you do that?
Very awkward.
It doesn't come out nice? Oh, I want to show you something, guys. Too many teachers don't show their students this. If we go second trace and pick maximum, because this one's opening down, I hate scrolling around. Sometimes it takes forever. You can type in numbers here. This vertex looks like it's between 0 and 5 somewhere, right?
Yeah.
So you can type 0, enter, 5, enter, enter again because I don't want to guess. And it will tell you where the maximum is. You don't have to scroll left and scroll right. You can type in a left bound and right bound number.
This is not that. Well, I got 2.9. 7.
Yeah, I got 3. Yeah.
I got 2.9.
Yeah, that's what I got. 3.0.
It depends on where you put your. We probably get a more accurate answer.
Yeah,
Much more than I say.
All right, now, I did get some calculator error on mine. The reason I got 2.9999999 is because it took those two values I picked, which were 0 and 5, and it did what's called iterations. It went smaller and smaller and smaller until it got as high as it could. But if I type a 3, enter right now, It says 326 is actually the value that's on the. Okay, it's just calculator error, just round. All right, 326. What else are we supposed to write down? Axis is x equals
3
and it opens down. Okay, let's try the other one. What's the other one? 12 minus 6x plus 5x squared. Thank you. All right, I'm going to leave my window the same and just see what happens.
Worked out pretty well. Here's this being
I don't like that that's back.
Okay.
Backward order.
What do we use this time instead of maximum?
Minimum.
Minimum.
Well, calculator. What's the thing here?
Let's get so off. -1, enter, 2, enter. That is not what I got. I got 0.6 and 10.2.
I got 2.2.
Someone get a value?
Yeah, 0.6.
0.6 something?
10.2.
Okay, I'm gonna pick minimum this time. And it looks really close. I'm just gonna say between like 0 and 2.
I did -1 and 2.
I got a minimum at.
That's not right. You gotta retype when you're
I don't think I hit 0 and 2. Minimum is 3. My left bound is 0, enter. My right bound was 2, enter. Enter. Stupid thing. Come on.
Now your calculator's frozen.
Okay. 0.6, 10.2. Is that this problem or this is the next one? I'm on E, right? That's the vertex, so the x-axis or the axis of symmetry is this, and it opens up. Are we okay?
No, we're good. I think. Katie and I are good. I don't know, how did they draw? They used to like draw on this thing. No, they just draw pictures.
I don't know how to do it. I tried one time.
Can you just like font those things?
No, not really. You have to go to draw button.
There is a draw button? Yeah. Oh, here it is. Second draw is not a program.
Usually there's an option that says
It's draw. I'm going to like go home and
pen. I don't want that right there. I don't know how to like work it. Oh, look at that.
enter.
You gotta like enter and then like.
Wait, second draw. You should put clear draw. Now it's
Mine's not drawing anymore.
I think maybe draw. So cool.
Yes,
I
because
have right
you have a staff line on, so you need to go up arrow, enter, and then hit grab. And I don't know if you changed your window yet or not. This one's out at the top. If you don't change the window, you gotta make the Y bigger. So make your Y max like 50.
I'm making Skype.
This is how I'm going to entertain myself.
I'm making Skype.
Okay,
It's a good etch-a-sketch.
we only have 11 minutes left and we have a whole side of the worksheet. Here we go. Number 4, part 4, these are all the same, so if we do 2 or 3 of them, we'll be good. 3 or 4 of them, we don't have to do all of them. All right, it says to start with vertex form, which is y equals a x minus h quantity squared plus k. Then find the stretch, which we call a, by putting in another point for the x and the y and solving for the a. That'll make more sense after I do an example. Okay. This point is 2, 1. Everybody okay with that? Can you read that? Okay. It's over 2 and up 1. So that is the vertex. So I know already that I have this. I'm almost done already. Does that seem okay? Anybody lost? All right. This is the a value that I have to try to figure out. To try to figure that out, I'm supposed to put in an x and a y from somewhere else on this graph. I'm going to go with this point right here is 1, 2. Some of you already figured out what that means a is. If I plug in the 2 here, because it's a y, yes, and this is a 1 for the x. Now we only have one thing missing, the a. So we have 2 equals negative 1 squared is 1. So what's a times 1 plus 1? This is really just 1a, right? Everybody's good with that?
Yeah.
Okay. So the stretch was just a 1 on this one. There was no stretch. All right. B is obviously going to have a stretch because it's got one kind of a number out in front. A negative. All right. I'm going with, be careful, I think there's a mark here and a mark here. So I'm going negative 2, 3. So someone start me out. What does the vertex form look like? Something times. Okay. To figure out this a, some of you could figure it out from the graph and counting, but what's going on if this is the point negative 1, 0? Y is 0 and x is negative 1. Yep, perfect. Negative 2 plus 1 is 1. Squared is 1, so we still have a. Does it make sense? Do you remember what we did yesterday? How we said we went over 1 and multiplied by the stretch, so it went down 3. Does that work from the vertex? Okay. So can you try C? Be careful on C. It is negative 2, negative 2. And you could use 0, 0 would work. You can't plug the vertex back in, guys, because there's no stretch at the vertex. Does that kind of make sense? The vertex isn't going to help you find the stretch because the parabola hasn't been stretched. What did you get? A type. Guys, this is multiplied together. You can't do 4 minus 2 back here, right? This is a 4a minus 2. Okay, which I already added to the other side here. And that's not 2, it's what? 1/2. So final answer?
Y equals 1/2 x plus 2 quantity squared
job. Okay, do you see how you would do D and E? They're even easier because you don't have to find the ordered pairs, right? They already gave them to you. All right, we have 5 minutes left. Let's look at this application problem. I think we can do it. All right. From the top of a building, a toy rocket is shot upward with an initial velocity of 132 feet per second. The formula below gives the height of the rocket above the ground at time t. Assume that t equals 0 when the rocket left the launch pad. If h equals, and I didn't make you come up with the equation, I will eventually have you plug the numbers in, but this says negative 16t squared plus 132t plus 60, where h is the height in feet and t is the time in seconds. Okay, I want you to think about how you could solve this algebraically and how you could solve this graphically. How tall is the building? It says at time t, the rocket left its launch pad, which is at the top of the building. Apparently it says from the top of a building. So you would put in t equals 0 and it would come out 60 feet. Now, this you could just plug in t equals 3 and t equals 8, but I'm going to have us do it on the calculator because I want to save time and I want to talk about an appropriate window. So go to y equals and type this in real quick. Negative 16x squared. Don't use t, won't work in this mode. Plus 132x. Plus 60. Eventually you will be graded on whether you can find an appropriate window. On this question, the x stands for time. Can we have negative time? So your window should not include any negative x. So I'm going to change my x min to 0. The max would be how long until it comes back down and hits the ground. I'm just going to leave it 10 and see what happens. The y value stands for what in this example? The height. So the y min, you could do 0 for the minimum, right? You could leave it negative 10, I really don't care, but the height of the rocket isn't going to be negative unless it burrows under the ground, right? Okay. The maximum, well, it started at what? 60, so it's got to go up really high. I don't know. I'm gonna put in 300 and see if that's high enough or not.
What about 900?
I don't think my window is right, or I typed something wrong, because it shouldn't look like that. Oh, I forgot an X in here.
What did you put in?
What does the maximum need to be, guys?
I'm just going with 900. Yeah, 900 is a little too much.
500 is enough? Okay.
I got about 350 that fit in.
Okay. So 350 or above, I'm going to go with 400.
That's what I did. Hey.
You can, guys, there's not any, I'm not going to give you a grade based on, it just has to be that it fits in that window and it's appropriate. It is not appropriate to have negative time or negative height. Okay, guys, please, we got 2 minutes left. All right, so the fast way to find its height at 3 seconds is just go, you can use the table. Some of you are great fans of the table. I would just go trace 3, enter, and it would tell me its height at 3 is what?
Oh, didn't work. I hit trace. 3. It's not working.
Enter. Are you on your graph?
I was. Yeah, I was before.
Is it in your window?
Yeah.
So now trace,
Yeah, I hit trace.
then the number 3, and then enter.
When I hit 3, it brings me back to that.
You have to be on the graph.
Yeah, I was on the graph. Oh, okay.
Trace 3, enter, trace 8, enter. Otherwise do value, go second trace. I'm not talking about second, but you can go to second and then pick value. At 8, I got 92. When did it hit the ground? What do we want to find there? The x-intercept, which is called a 0. So you go second trace, you pick 0. Now you can do your guessing thing again. I'm thinking it's somewhere between 8 and 10 seconds. All right, and I got, can anybody read that? 8.7. Okay, then we find its maximum, and it wants the x and the y. Yes, please do.
Yeah, I turned in the wrong sheet.
Yes, you did.
Yeah.
And I forgot to pass the homework checks back. All right.
You want to just put in the bin?
I'll take it. Thank you. You're good.
Okay. Yeah, you might get it.
All right, so I got the maximum height was reached at 4.12 seconds, and the maximum height is this 332.25 number. Okay, the last question says, when is it exactly 300 feet? I would actually type in a y 2 of 300 feet, or just 300. And then what I actually want to know is the 2 intersection points here and here. So it's second trace, intersection, and you can just go enter, enter, enter. And it says at what times, so 5.54 is one of the times. To find the other time, guys, I'm recording. Could I just finish? Second, and I want to find the other intersection point. So I'm going to go enter, enter, but I'm going to scroll over for my guess to the other one. Ever so slowly, apparently. So the other one is at maybe 2.7 seconds. That was this intersection point over here, yes. And what did it actually ask? Was it exactly, so it, I don't know about, I didn't round necessarily, but at 2.7 seconds and at 5.5 seconds or 5.4, it hit exactly 300 feet or approximately 300 feet. And we did that by graphing y equals 300. All right, that's not what it looked like. It was way up here, wasn't it?
Close enough.
It was up here somewhere. All right, anyway. I don't know why it won't let me move that line.